Hi kids, I hope everybody is fine. So this video is for class 10 student and we were solving sums from the chapter Circles from M L Aggarwal, exercise 15.3 based on tangent and secant properties, and we have already done till sum number 29. For the previous video you can see the link in the description box. Let us start from sum number 30A, exercise 15.3 M L Aggarwal. In the figure given below, PAB is a secant and PT is a tangent to a circle. If PA is to AB is 1:3, find, and PT is 6 centimeter, find the length of PB. Very easy. Look over here. First of all, PA is to AB is given as 1:3, which means can I write PA as X and AB as 3x, where x is the common factor? Definitely. So PA is x and AB is 3x. So what is PB? So PB will be 4x. Now we have the theorem. If a tangent and a secant and a chord rather meet externally, then the square of the tangent is equal to the product of the length of the segments formed by the chord PA into PB. That's my theorem. Yes or no? Utilize it. PT is 6, so 6 square. PA is x. PB is 4x. Look carefully, this is 36. This is 4x square, which means 36 by 4 is 9 equals to x square. X equals to plus minus 3. Because from here we can write x equals to plus minus root 9. Root 9 we know is 3. We won't take the negative one, we take the positive. So x is 3. They are asking PB. So PB will be 4 into 3. That's 12 centimeter. Done. Very easy. Just use this theorem. PT square equals to PA into PB. Chalo. We look at 30 part B now. Now look at 30 part B. In the figure, ABC is an isosceles triangle in which AB is equal to AC. Q is the midpoint of AC. If APB is a secant and AC is a tangent to the circle at Q, prove that AB equals to 4 times AP. Very easy. Just now we have used the theorem that when a tangent and a chord meet externally, then the square of the tangent is equal to the product of the length of the segments formed by the chord. Now look over here. Which means in this case, AQ is a tangent, so AQ square will be equal to AP multiplied by AB. Yes or no? Okay. Now Q is the midpoint, so AQ is half of AC. Yes or no? I can substitute because Q is the midpoint. Now AC equals to AB, so I can substitute half AB whole square equals to AP multiplied by AB. Just open the bracket, so this becomes AP square by 4 is AP multiplied by AB. AB and 1 cancels out. So AB equals to 4 goes over there. 4 times AP. This is what was required to be proved. AB equals to 4 AP. See, 3 steps and the sum is done. Very easy. Same logic, AQ square equals to AP multiplied by AB. When a tangent and a chord meet externally, then the square of the tangent is equal to the product of the length of the segment formed by the chord. Clear? Chalo. We'll do the next one now. Now look at 31. Pretty easy. Two chords AB and CD of a circle intersect externally at a point P. First of all, let us draw the diagram. Then I'll read what we need to prove. There are two chords, okay, A, B and CD. They intersect externally at a point P. If PA is equal to PC, PA and PC are equal, prove that AB and CD are equal. Very easy. Look. First of all, we know if two chords meet externally, then the product of the length of the segments formed by the two chord will be equal, which means can I write PA multiplied by PB is equal to PC multiplied by PD. Can I write like this? When two chords meet externally, then the product of the length of the segments formed by each chord will be equal. So now PA and PC are equal. So we'll get PB equals to PD. So this and this length are equal. Yes or no? Now look carefully. PA equals to PC. Given PA, can I write AB plus PB? And PC, can I write CD plus PD? I can. PB equals to PD. So that cancels out. So what remains? AB equals to CD. This is what we were supposed to prove. Very easy. Okay? Sure. We'll do the next one, 32 now. Now look at this sum, 32 part A. In the figure given, AT is a tangent to the circle at A. Angle BAT is 45 degree and angle BAC is 65 degree. Find angle ABC, this angle. I think in 2-3 steps this sum will be done. First of all, see, we have done that if this is a circle, this is your tangent, and if you draw a chord like this, then this angle, the angle formed between the tangent and the chord and the angle formed in the alternate segment will be equal. Yes or no? Angle in alternate segment. Similarly, angle BAT, look carefully, angle BAT will be equal to angle ACB. Angle in alternate segment. Please write the reason also. Angle in alternate segment. The angle formed between the tangent and the chord is equal to the angle formed in the alternate segment by the chord. Okay. So angle BAT is how much? 45 degree is equal to angle ACB. So this angle we got 45 degree. Suppose this is X. Now look carefully in triangle ABC. When you add all the angles, interior angles, you get 180 angle sum property. So this is X equals to 180 minus 110. So X equals to 70 degree, which means angle ABC is 70 degree. Done? It was very easy. Only one property we used, angle in alternate segment. Done. Sure. We'll do the next one now, 32 part B. Look at 32 part B. In the figure given below, A, B, C are 3 points in the circle. The tangent at C meet AB produced at T. Given angle ATC is 36 degree and angle ACT is 48 degree. Calculate the angle subtended by AB at the center of the circle. Look, suppose this is the center of the circle, O. We'll write over here. Then we need to calculate this angle. The angle AB subtend at the center. Now first of all, look, what we'll do, join BC. Join BC. Now look carefully. For triangle ATC, just look carefully. This plus this will give you this now. Exterior angle equals to sum of opposite interior angle. We know this. Angle CAB will be equal to angle ACT plus angle ATC. Exterior angle is equal to sum of opposite interior angle, or you find this angle sum property, and then you calculate this linear pair, whatever you want to do. So angle CAB is 48 plus 36. That's how much? 84 degree. This is 84 degree. Done. Now look carefully. This angle and this angle will be equal. Angle, look carefully, angle ACT will be equal to ABC, which is equal to 48. Why? I'll just explain. angle in alternate segment. How come? CT is a tangent, AC is the chord. So the angle between the chord and a tangent is equal to the angle formed in the alternate segment. Yes or no? So AC forms an angle over here in an alternate segment, and the angle between AC and tangent is 48. So this is 48 degree. Done? Now, in the triangle ABC, if you look carefully, this angle, suppose I take it as X. So X plus 48 plus 84 equals to 180. Any doubt? Angle sum property. The three angles add to give 180. Now solve it. So X plus this is 132 equals to 180. So X is 180 minus 132. So X is 48 degree. Yes or no? Let us see. Yeah, X is 48 degree. Now, this angle is 48 degree. We have one theorem. Angle at the center is twice the angle at circumference. So, if this is Y, then Y will be twice of X. Look carefully. Angle AOB will be twice of angle ACB. Angle at the center is twice the angle at the circumference from the same 2 points. See, AB, AOB, ACB. So you can say this is twice into 48. That's how much? 96 degree, which is Y is 96. Or angle subtended by AB at the center is 96 degree. Done? Step by step. Okay? Chalo. We'll do the next sum now. Now look at 33. In the figure, triangle ABC is an isosceles triangle with AB is equal to AC. Prove that the tangent at A is parallel to BC. Prove that the tangent at A to the circumcircle of the triangle ABC is parallel to BC. Which means, in short, we need to prove that AT is parallel to BC. Okay? ABC is an isosceles triangle, so AB is equal to AC. That is given to us, which means this angle and this angle will be equal. Angle ABC will be equal to ACB is equal to X. Let. Why they are equal? Because AB is equal to AC, and in isosceles triangle, we remember that the angle opposite to equal side are equal. So these two angles are equal. Now look carefully. This angle, try to understand, and this angle will be equal. The angle formed between the chord and the tangent is equal to the angle in the alternate segment. Which means, can I write angle TAC is equal to angle ABC? Angle in alternate segment. Yes or no? Which means if this is X, this is X. Yes or no? Now look carefully. Third step. Angle ACB is equal to angle CAT is equal to X. Yes or no? These two angles are equal. And when will this happen? This will happen only when BC is parallel to AT by alternate angle property. Try to understand. If these two lines are parallel, if L1 is parallel to L2, then this angle and this angle are equal. And this angle and this angle are equal. Alternate. Yes or no? If. Now the converse. If these two angles are equal, or if these two angles are equal, it simply means L1 and L2 are parallel to each other. The converse. So if these two angles are equal, we can say that BC is parallel to AT by alternate angle property. And that is what we were supposed to prove. It simply implies that the tangent at A to the circumcircle of triangle ABC is parallel to BC. Done? Very easy. Chalo. We'll do the next one now. Look at 34. if the sides of the rectangle touch a circle, prove that the rectangle is a square. See, it means you have a circle. Try to understand. Yeah. Suppose A, B, C, D is a rectangle. It's a rectangle. It means opposite sides are equal and all the angles are 90 degrees. We need to prove that if the sides of this rectangle touch a circle, you can see the figure, prove that this is not a rectangle, that this rectangle is actually a square. Now, very easy. Look over here. First of all, suppose E, F, G, H. Now, AH is equal to AE, yes or no? Because tangent from an external point are equal on a circle. So AH and AE are tangents. Similarly, HB is equal to BG. Yes or no? Similarly, DF is equal to ED. FC is equal to EG. CG, sorry. Yes or no? FC equals to CG. This and this are equal. This and this is equal. This and this is equal. And this is equal. Yes or no? What I'll do? Add. So AH plus HB plus DF plus FC is AE plus ED plus BG plus GC or CG, whatever. AE, ED, BG and GC. Now look carefully. AH plus HB is AB. DF plus FC is DC. AE plus ED is AD. And BG plus GC is BC. Now, ABCD is a rectangle, which means opposite sides are equal, which means AB and CD will be equal, which means AB will be equal to DC. So I can write AB plus AB. Similarly, AD and BC will be equal. AD and BC will be equal. So I can write AD plus AD. So twice of AB is equal to twice of AD. Look carefully. So AB is equal to AD. In a rectangle, if the adjacent sides are equal, it becomes a square. We know that. So which means AB is equal to AD and AD is equal to BC and BC equals to CD. Yes or no? All the sides are equal and all the angles are 90 degrees, which simply implies it is a square. The rectangle is a square. Done? Pretty easy. Chalo, we'll do the next one now. Now look at 35 part A. Very easy. In the figure given, two circles intersect at A and B. From a point P, on one of these circles, two line segment PAC, PBD are drawn, intersecting the other circle at C and D. You can see the figure. Prove that CD is parallel to the tangent at P, which means we need to prove that CD is parallel to TP. Just now we did a sum like this. Look carefully. First thing, AP is a chord and PT is a tangent. So this angle, try to understand, and this angle will be equal. Angle in alternate segment. AP forms an angle ABP in the alternate segment. And TPA is the angle between the chord and the tangent. Angle TPA is equal to angle ABP. Angle in alternate segment. Try to understand. Done. Now look carefully. Look at the bigger circle. ABDC. ABDC is a cyclic quadrilateral. And in a cyclic quadrilateral, the exterior angle is equal to opposite interior angle. Because this angle and this angle are supplementary. So we can write that angle ABP is equal to angle ACD. Exterior angle equals to opposite interior angle in case of a cyclic quadrilateral. If, try to understand, this angle and this angle are equal because these two angles are supplementary. Okay, now look carefully. Suppose this was x degree, this is x degree, this is x degree. Now look, angle CPT is equal to PCD and this only happens when PT is parallel to CD by alternate angle property. Again look carefully. This is CD. This is PT. Look carefully. Suppose if these two are parallel, then this angle and this angle are equal. Now the converse, if these two angles are equal, then these two lines are parallel. Yes or no? By alternate angle property, which means PT is parallel to CD, which means CD is parallel to the tangent at P. Proved? Chalo. We'll do the next one, 35 part B. Now look at 35 part B. In the figure given, two circles with center C and C dash intersect at A and B, and the point C lies on the circle with center C dash. PQ is the tangent to the circle with center C dash at A. You can see. Prove that AC bisects angle PAB. AC bisects angle PAB. AC, C is this point, center of the smaller circle, bisects PAB, which means this angle and this angle are equal. We need to prove that. Very easy. First of all, look, CA and CB are equal because that's the radius of the smaller circle. Look carefully. Smaller circle, because for the smaller circle, C is the center. So CA and CB will be equal, the radius. Now look carefully. CA is the chord for the bigger circle. And at A we have a tangent PQ. So angle PAC will be equal to angle CBA. Angle in alternate segment. Try to understand. CA is the chord, PA is the tangent, so the angle between the tangent, that is X, and the angle formed in the alternate segment by the chord, these two angles will be equal. Yes or no? Now CA and CB are equal, which means triangle ABC is an isosceles triangle. Yes or no? Because AC and AB are equal, which means angle CAB will be equal to CBA, will be equal to X, because the angle opposite to the equal side are equal, which means if this is X, this is X. Now if you look carefully from this and this, we can say that angle PAC is definitely equal to CAB X. Yes or no? From these two, which simply means CA bisects angle PAB. Done, because both the angles are equal. Very easy. Okay, chalo, we'll do number 36 now. Now look at 36 part A. In the figure given, AB is the chord of the circle with center O. BT is a tangent to the circle. If angle OAB is 32 degree, find the value of X and Y. Pretty easy. Look over here first of all. In triangle AOB, OA equals to OB, that's the radius. Yes or no? Which means if these two sides are equal, then this angle and this angle will be equal. Angle OBA will be equal to OAB, will be equal to 32 degree. Yes or no? Yes, because the angle opposite to the equal side in an isosceles triangle are equal. Now, this is 32, this is 32. So what is this? angle AOB plus 32 equals to 180. Angle sum property. So angle AOB is equal to 180 minus 64. So angle AOB is equal to 116. Am I correct? Yeah. So this is 116. Done. Now look carefully. Angle AOB is twice angle ACB. Angle at the center is twice the angle at the circumference. AB, AOB, ACB. Yes or no? So this is 116 equals to 2y. So y equals to 58 degree. Done. Now look carefully. AB is the chord. BT is the tangent. So the angle between the chord and the tangent is equal to the angle formed in the alternate segment by the chord, which means x equals to y. Angle in alternate segment, which means x and y are equal, and that is equal to 58 degree. Very easy. Sure. We'll do the next one, 36 part B. Now look at 36 part B. In the figure given, O and O dash are centers of two circles touching each other externally at the point P. The common tangent at P meets the direct common tangent AB at M. Okay. Prove that M bisects AB, which means AM equals to MB, we need to prove. And prove that angle APB is 90 degree. Very easy. Just look over here. AM equals to MP. Yes or no? Because AM and MP are tangents to the bigger circle from an external point M. So AM and MP will be equal. Tangent from external point. They are equal. Similarly, if you look carefully, BM will be equal to MP. Again, same reason. BM and MP are tangent to the smaller circle from an external point M, so they will be equal. So from these two, we can definitely say AM equals to BM, AM equals to BM. Now try to understand. AM equals to BM, which means M is the midpoint of AB, which means M bisects AB. Done the first part. Okay. Now look. AM equals to MP, which means AMP, triangle AMP is an isosceles triangle. Yes or no? AM equals to MP, which means this angle and this angle will be equal. Angle MAP will be equal to angle MPA. Suppose X. Let. So if this is X, this is X. Yes or no? Okay. Now look. In this triangle, in triangle MBP, again MB is equal to MP, we know. So these two sides are equal, which means this angle and this angle will be equal. Suppose Y. Suppose angle MBP will be equal to MPB. Suppose Y, because it's an isosceles triangle and angle opposite to equal side are equal. Now look, in triangle ABP, X plus Y plus X plus Y will be equal to 180. Angle sum property, which means twice X plus twice Y equals to 180. 2 taken common, X plus Y equals to 180, which means X plus Y is 90. Yes or no? And what is X plus Y? X plus Y is nothing but APB. So angle APB equals to 90 degree. Proved. Very easy. This triangle is an isosceles triangle. X, X. This is an isosceles triangle. Y, Y. Add all the angle. It equal to 180 degree. Then you get X plus Y as 180 degree. Chalo. This was the last sum for this exercise. So at last this chapter is over. In the next video, we'll start with some other chapter. Till then, take care and be safe. And if you like the video, do subscribe and share with your friends.